Okay, thank you. Thanks all. Thanks all for joining, and then let me start. Okay, so this presents the new latest release of Oracle Sharding, and as well as how we are going to implement or install the Oracle Sharding in the 12c databases. So to start with, what is Oracle Shard? What is basically a sharding is? Sharding is a type of a database of which partitioning that separates very large database into smaller, faster, or easily managed parts called data shards. The word shard means a small part or of a whole, and it is completely a partition. And each of these databases are isolated and which is not shared at all. So a mechanism for horizontal scaling, distributed data sets or a tables or a data over multiple servers or a databases. Each shard is an independent of databases. All shards consist a single logical database. When you look at combining of all shards, a single logical database, its unit is representing. So before Oracle sharding, what are all other database vendors or what other databases have this sharding mechanism is NoSQL databases predominantly of Cassandra, MongoDB, CouchDB, etc. And we also have MySQL NDB cluster, MS SQL sharding, DB2 partitioning or sharding. So there are other database vendors which already have in this sharding field. So they were all. Now, Oracle has released white paper, and comparing with Cassandra and Oracle sharding, the linear scalability, the replication features are in the Cassandra, but rest of all, especially the relational joins, transactions, predefined queries, multi-sharded queries are not possible in Cassandra. And out of all, the other key aspect is with the NoSQL database is the ACID transactions. The ACID transactions are basically to give you a consistent view of the data. So when you really take the NoSQL databases sharding, one of the basic mechanism that actually flows into is the CAP theorem and consistency. So majority of the NoSQL databases have eventual consistency unless you don't set your consistent mechanism in the database itself. So that actually loses your database ability to give you a consistent view of the data, where Oracle comes up with a relational database background and then gives you the consistent approach of a consistent view of the data is a very, very big thing in the Oracle sharding. So these are all the major comparisons with comparing to MongoDB and Cassandra. And if you look at Oracle RAC versus sharding, when you look at Oracle RAC, it is a single physical database shared by multiple nodes or servers with a shared disk architecture. It supports any types of applications. And when it comes to Oracle sharding, n number of servers with n number of databases, and each database is an isolated data view of a part of the data which is showed. A single logical database, if it consists everything, it's predominantly used for OLTP, designed to use an OLTP type of applications rather than analytical type of applications. Okay, so why Oracle sharding? Why don't we use NoSQL databases or any other databases? First and foremost thing is that Oracle combines all these rich features like connection pools, Oracle notification services, sharding software, a partitioning, and out of all, you got all the performance metrics instrumentation in Oracle database. And it's a fully ACID compliant database. It supports relational schemas that define structure as like we have. Sharding is no more and NoSQL proprietary anymore. Database level partitioning, use Oracle rich partitioning features. And as I said, ACID properties and read consistency. This is the very, very good feature according to my understanding, comparing to other NoSQL databases. And one of the basic problem that majority of the developers or the DBAs feel with the NoSQL databases is the SQL and the programming interfaces. When you want to write a query basically in MongoDB or Cassandra or in any other general NoSQL databases, you find very, very, like a kind of a JSON type of writing format you want, unless you don't use any other tools. But when you when you want to really use Oracle sharding, you just write a plain query as like you want. So that's the biggest advantage for the SQL based developers when it compares to NoSQL databases. And you can also have a multiple types of databases supports as like your data, and you can do online schema changes as well. When it comes to, you can keep multi-core capacity, you can increase your cores under the systems, and it supports high availability features. You can keep a data guard or even rack within single shard, or within the single shard you can keep a rack for high availability, or also you can keep a data guard, and data guard is tightly integrated with Oracle sharding. So we'll see that. So what kind of considerations we need to take before we do the sharding? Licensing is one important key thing that before you want to test it. Just give me one sec. I'm sharing everything. Let me share. Hold up. Can you guys, someone confirm, can you see the screens properly? So let me and come back. So now, can you see the page changes? Okay. So let me. Is that okay now? Okay. So sorry guys. So these are the slides that I have missed with you. Before Oracle sharding, we have Cassandra, MongoDB, CouchDB, MySQL, MSSQL, DB2, partitioning and sharding. When it compares to your NoSQL and MongoDB, so this is what it has. This has the rich features of relational schemas and joins, predefined queries, and multi-shard queries. It's possible. Wherein the Cassandra and MongoDB have some limitations with eventual consistency, having a cross-shard queries and ACID transactions especially. When it comes to don't know what's happening. Okay, this is the second slide. Sorry. Okay, so can you see the third slide? How? Is that fine now? the same thing. Shared one. Okay. Okay. Let me give it a try. Okay. Okay. Thank you. Someone is messaging me. Thanks for that. Okay. So these are all the previous slides for you. So what is sharding? A mechanism for horizontal scaling distributed data sets. Each shard is independent of database. All shards consist of a single logical database. When it comes to before Oracle sharding, we have Cassandra, MongoDB, CouchDB, MySQL and DB cluster, MS SQL sharding, and DB2 partitioning and sharding. So when it compares to MongoDB and Cassandra, Oracle has rich features comparing like ACID transactions, relational joins, and also multi-sharded queries are possible with Oracle sharding, not possible with Cassandra and MongoDB unless you set some specific consistency level and some specific um, uh, uh, a routing level to the shards especially. So comparing to Oracle RAC and shardings, Oracle RAC is basically a single shared disk architecture which having multiple nodes access the same database. Where in Oracle sharding, you have the databases are partitioned across and all the tables have been partitioned across to the nodes and each node is act independently and it's represents a single logical database. Oracle sharding generally designed for an OLTP type of applications. It's a fully ACID compliant database, and it comes with rich features like your connection pools, Oracle notification service, sharding software, and partitioning. It's predominantly used partitioning feature. All the shards works as a partitions. Now, when you really look into why we need to use Oracle sharding, is this one relational NoSQL databases. It has NoSQL databases have basically a no structure or no schema defined. It's schema on read kind of. This is the major feature for relational schema sharding, and sharding is no more than a NoSQL proprietary. Database partitioning, Oracle uses rich partitioning features to do the sharding, and it also gives you ability of doing ACID properties and read consistency, which we are talking long time from with the NoSQL databases about eventual consistency. I will give an example with eventual consistency. When you open a LinkedIn, you see a number of views of your post, maybe lesser than what you see in mobile, when at the same time, in fact. So that's the reason. Your query in the mobile can go to one of the shards and get a different consistent view of it rather than a specific view, consistent view of it. So that's basically an eventual consistency. So in applications where you do have an eventual consistency kind of, it doesn't matter. So you can use that kind of databases. But if you want a read consistency and you want to have a distributed processing systems, you must have something like an ACID properties database, which ACID compliant property database, which Oracle can give you back. And one of the important features is you can also create your shards with RAC and data guard. So you can keep data guard if you have, and you can also use RAC for each of these shards individually. So that's a high availability feature support also there for Oracle sharding. And what are the considerations to do for Oracle sharding is the licensing is the first and foremost thing. You may need the sharding license and partitioning license if you don't have. And the application suitability. Generally, OLTP application suits best with relational data distributed to single node and access through that node. Design of relational schema table. This is the very key important when you really design any distributed databases. So if you have a table, you must specify a distribution key so that based on the distribution key, your data will be partitioned or distributed to the other nodes. Any other NoSQL databases, any other relational sharding databases, it must have to use the distribution key to distribute the data. So it's not a rack, it's a distributed database partitioning system. Existing databases must have to redesign to partitions and ensure application suitability as well. So if a common question comes, how about an existing database? Like how we can keep an existing database into a shard? No, we will strictly say no. The reason is we can do that in a different way, but before to that, we must ensure all of your tables or some of your tables, whatever you want, should be designed in such a way, like distribution key, and also you need to recreate the table by using some separate syntax. So that's why existing database keeping into a shard, it's not best to do. There's an options to do, but it's not best to do. We will keep it as a separate database and new database, load the data into a sharded table, and then distribution of data can be possible. So keep in mind, if you want an existing databases need to be moved, you need to think of twice. Okay, so sharding licenses, according to the white paper that have been given, if you have a less or equal to less than 3 or equal to 3 primary shards, if you have an enterprise license which includes data guard and partitioning, you don't need to pay for it, Oracle sharding license. So if you plan to have a RAC, Golden Gate, and data guard along with sharding, you must have those licenses for these options. But if you want to create more than 3 primary shards, you must license along with one of the data guard or high availability options. So generally, if you want to test or if you want to implement and do that, if you have lesser than or 3 primary shards and you have an enterprise license already, which includes a data guard option, you don't need to pay for that. ULA, unlimited license or agreement. If you organizations have unlimited license like banks and insurance companies, and those have, and they all come with enterprise editions, RAC, and other options also, then sharding is at no cost. So that's where you have already the source white paper you have. If you can go and read that, that's there. Okay, sharding. Sharded database catalog. It's like our RMN catalog, what we have. So we have to call SDB. This SDB can be also part of your enterprise grid RMN catalog database you can create, but it has to be on 12 series too. And the second component, it's an independent Oracle databases on each node. There is other thing also we need to have is software as a grid control software. There is a GADS software, GDS CTL tool, which you need to install apart from the Oracle Home. And you also need the shard catalog, which contains the shard database. Shard business that listens to the connection of the sharding. This is an example in MongoDB or any other root kind of stuff. Directors will help you to redirect your connection, redirect your queries, and read the metadata from the shard catalog, and then send that particular query to particular shard, something like that. Connection pools, as we all know that you can have a pool of connections between this routing and those stuff. So you can also have the connection pools in that. And the management interfaces, the key management interface as like SRVCTL or CRSCTL, you have GDSCTL, command line utility, to manage the shards and to create shards and adding or deleting or whatever you can do. So this is basically a general view of the sharding architecture, which is a changed one from the Oracle documentation. So as an example, you create a SDB database, that's a shard database which includes your shard catalog, and you create your connection pool with the global service, a common service that which can connect to this SDB, and you can redirect your queries to each and individual. If you see this is a database running on shard1 host and shard2 host, and your table customer is partitioned, one partition store here, another partition store here. If a customer fire a query on this database, it goes to first a connection pool, and then shard director will listens that, and then it searches the metadata within the sharded catalog. What is a metadata? So if I create a table with a sharded key, or a distribution key, the actual table definition stores here, not here. So the definition stores here and it tells what are all the partitions and the related table spaces stored there. So that's the metadata. So we store that information and the metadata here and then send that data. Request can go to particular shards or all the shards, get the data and send it. So in this case, if I say this query, it may be residing here, it may be residing here, or some part of the data is residing here or some part of the data here. So it has to go to both of the shards, get the data and send back to you, to the client. So the distribution of data can be different. You also can keep a standby nodes for each of the shards, as like you create a normal standby for each of the database. And Oracle Sharding is tightly integrated with DataGuard, and you can use a DataGuard broker to configure from the GDSCTL itself to configure your standbys. Okay, how the data is distributed across the shards using the distribution key. The table with type of sharded table, one of the column need to be specified as a distribution key. This is common in any other distributed. Distribution key can be a type of consistent hash or a, the distribution metadata is stored in JSON catalog. The table now created in multiple shards are databases, evenly distributed, called chunks to each shard. So general terminology of shards in Oracle is called, first thing is a sharded table. It's a basic distributed table across partitions. And if you want to combine 2 or 3 particular sharded family, called sharded table family, it's basically in our Oracle we have a cluster. Sharded table family can, for example, you want to keep one particular family for master and detail table, you can keep duplicated tables. In addition to sharded table, created duplicate tables with the filters, queries, or a meterless view. It's a meterless view refresh. You can also do whatever the objects you want to create, you can create. But if you specify a table, that's sharded. You can create roles, functions, anything as like the normal database, you can do that. When it comes to the DDL execution, it is all to do a DDL commands through a shard rather than directly executing on the shard 1 or shard 2. The reason is that all of our metadata sitting in the catalog, rather than you go and fire on the shard 1 and shard 2, which creates an inconsistency, you should do it in the SDB database. And there are some changes to accommodate the sharded table creation, duplicate table creations. Oracle introduced some changes to the DDL extensions, DDL syntax extensions. So storage attributes is basically called as a partitions, table space sets, and chunks. So partitions are, we all know what partitions are, subpartitions are, and the table spaces, whenever we create a partitions with the tables, it automatically create the table spaces as well. And if you want to group all these table spaces, you can specify the table space set, and each of these chunks can have all this one. So let's see. So sharding methods, we have 3 types of sharding methods. One is system managed sharding. It's basically use a consistent hash or a linear hash, which is basically when you say create table, create sharded table, your constraints and your columns, and you specify partition by consistent hash, as like we do in our partition mechanism. And I say partitions auto, number of partitions, and I specify table space set. This is the change, the sharded and as well as the table space set. This is the change in the syntax that you want to create. Generally, if you don't specify any distribution key or anything, you just specify consistent hash or any other stuff, then it automatically takes a hash or a linear mechanism to distribute your data to the partitions across the nodes. So there is another type of partition sharding called composite sharding, which we all know by subpartitioning. Partition set by and consistent partitioning. If I specify this and what table spaces it need to go, it has to, the partitions will be created on that particular table spaces and the data will be distributed according to the nodes. Using subpartitions with sharding, again, you can do a subpartitioning. How we manage subpartitions in our Oracle, you can also specify that. So that means whole of this sharding concept is tightly integrated with partitioning. So if we are well aware of the partitioning, it's just need to mention what type of partitioning we need to do and the sharded table syntax. So that's it. You have to decide consistent linear hash. So ideally, if you don't want to manage what values, etc., and Oracle has to manage, if you want to, system has to manage that, you leave that consistent mechanism or a linear hash so that it takes either even distributed data or else consistently it will transfer the data to the other nodes. Okay, so this is the syntax, and say create table space set, and it creates that you want to create, it creates that. And also it introduce create sharded table space set, and what table space partitioning clauses you can do that. Limitations of sharded table: if you have created a sharded table, rename, add events, all operations on individual partitions are not supported on a sharded table. On the duplicated tables, these are all this: rename, add, modify column, constant, drop column. You can, because this is actually a materialized view at a table. So there are in the current release as well for the sharded table. So these are all the list. I'll not go further. You can read. How to connect to a sharded database? Sharded database by using a session-based request routing. You can also use your connection string can contain shard key, must contain actually shard key, so that it can directly go to that particular shard rather than different. JDBC connections are also possible by using connection set shard key. You can also use OCI or ODP.NET, and it supports PHP, Python, Node.js, and it has a very good rich features for API calls, methods also. But in addition to session-based routing, you can also have statement-level request routing. You can keep a shard key and then in your query itself, and then tell that it has to go to particular shard. So cross-shard queries also can be possible by using a GSM service to the SDB catalog database. So rather than you don't know which shard it is. So what you can do, you can connect a common GSM service like to the GSM catalog, and then GSM catalog will take care of routing your query to the different shards and get the data to your client. So how to implement? Like RAC, we have a lot of issues in RAC installation, private networks, fluffy, all this stuff. No, but it's simple. Let's look at it. So I've just given a test for that. What we need basically is we need probably 3 nodes if you want to implement. You need a GSM software additionally on the shard catalog database, on the shard catalog node. The other 2 nodes are basically a simple 12.201 installations, and it also contains something called scheduler agent. In beta release, we don't have a scheduler agent, but when Oracle releases 12 release to public, so we also have a scheduler agent automatically installed, so you need not to worry about that. So these are all the steps that we need basically to install. We just need to install on shard catalog, shard 1 and shard 2 nodes, can create a database using DBCA, and it should be CDB support is not yet there. Install GSM software as a separate home and do an environment setup. You can also do a SCAD database for sharding prerequisites, complete some of the prerequisites for sharding, and you can configure shard catalog using GSDCTL, and you need to start the scheduler agents and create shard groups, directors, and then add shards. So we will see all the steps. So this is the first step of it, where we all know about this, how to install. So that's the basic steps we have, and create a shard catalog database in shard catalog node, and then download your GSM software. Comes as separate zip file. You can download that GSM software and then install as a separate home, and then complete some of the prerequisite node, like destinations, open links. You also need to create JSM catalog user and my GDS admin user and some privileges. And you also need to open 880 port. In fact, if you want to configure anything from the DB Express or the Enterprise Manager console, it can. So you also need to register your particular node with the agent registration with particular password. You can keep that. And then in Shardcat, run GDSCTL with the GSM home location. And you first thing create shard catalog. What is node, port number, and the database name, service name, and how many chunks. It divides your partitions and tables into the separate chunks. How many that it creates automatically to that. So user, what is the user want, and what is the reason we can create. We can create multiple reasons onto that. And you can add GSM, a shard director, and then what port the shard director has to listen. And what is the catalog, this catalog, that. And you can start your GSM and then add a password and credentials. If you don't do this, your deployment will fail. So better we have to add a password here itself. And then on the shard 1 and shard 2 database nodes, you have, as you have installed only software, you just need to start scheduler agent start, scheduler agent status. You just check that. So it shows this. So you have to register your scheduler agent register database, Shardcat 8 port, it has to be registered. So you got. Once you've done that, the next thing you have to do is create a shard group. What is the shard group? You give any name, deploy as primary or a secondary or a standby. This tells us whether you are deploying a standby or a primary one region. And then invite node shard 1. So this is how we tell, add this node to this group, primary group, and then create shard. What is that shard you can create? And then again, you have to invite shard 2 node. So I have invited both of these nodes. And then once I have invited both of these nodes, I just need to say deploy the shard catalog. Now, this deploy procedure will automatically create databases in shard 1 and shard 2. Automatically creates that. If you start configuration also, it automatically configure the data guard as well. So it's all one-time job. So once you deploy all this, it will automatically, the DBCA runs remotely and then configure all your database according to the deployment. So this is pretty simple. Once you've done that, if you say config shard, it tells you what are all the shards, whether it is deployed or read-only, and availability and all. And if you say specifically, if you want to look at config shard sh2, it tells what are all the DDLs, how much disk space, what is the rack, etc., and regions, everything it tells you with the shards. How to connect to this? You can create a service, add service, service name, role primary or a standby. You can create a service, and this service can be used by your queries or your clients by connecting to the shard catalog database. So you can say config service, start service, and status. If you look at the status, this service is automatically created in both of these nodes. The TST service is automatically created in both of these shards. So anywhere it connects, it goes and then connect to that particular. Anything I want to do in the shard database, first and foremost thing, when you connect to the SDB, you must do alter session enabled shard DDL. If I don't do this, whatever commands I execute or DDL statements I execute, that will be to local. If I fire this alter session enable shard DDL, then whatever commands I fire, that will be populated or cascaded to the shard nodes as well. So it is must that you have to enable your shard DDL on the sessions and then do rest. So I have given some privileges and created a table space set using some template, and also created some table space product using local. So ensure that you must give session details. So I created a tables, create chart, table, customers, consisters, line items, and products. 4 chart tables created. Catalog database, if I verify what is my tablespace set, it is there. TSP set 1. Yes, fine. And it contains the partitions, all the partitions P1, P1, P1. And how many chunks I have, I also specified 12 chunks when I created my chart catalog. It's specifically distributed the chunks evenly between these two shards. Okay. Now, if I verify this database, log into the shard1 database and look at dbay tab partitions, if you see partition P1 and then automatically. And if you see orders, partition P7. So if you see 1, 3, 5, 6, and 7, 10, 11, all of these partitions have been segregated or distributed to different events, and the table space is also created automatically along with those partitions. So there are some maintaining shards. In the next part, I'm going to discuss adding shard, how we go to recover a shard, how deleting a shard, resharding and validating shards, and also some DML limitations we want to see. I have not fully tested that again, but I have to do that and then come back to that. Any questions? Thanks. That's it. Any questions? If anyone have any questions, I will answer. Any other questions you have? Yes, if sharding license is free, if we have unlimited license agreement with Oracle, yes, that's what the white paper says. And unlimited license agreement is basically includes your RAC, your data guard options, and along with partitioning. If you have that, yes. Please refer to that white paper for licensing part. And also, Oracle license changes frequently or something like that. Better you check with your Oracle manager as well whether you need a separate license for Oracle sharding um, with your license agreement. So the common question I have got from few of people through my blog is basically how an existing database is, how we can create an existing database. So I almost try to do that, but it says you have to create a sharded table and export and import again. So it's basically the same thing: create a new database, export and import what tables you want. So that's the better approach to do that, because when you do the export and import, the data distribution will do that. Important thing I forgot to mention in the presentation is that it's like your ASM disks, how your disks automatically rebalance the shard data. The partitions also automatically rebalance when you delete the data, when you actually export import. All the data will be distributed accordingly, evenly, or based on your sharding key mechanism. So this will be done even automatically without having any intervention. Suppose if you have a long gap or any other stuff, you can reshard or eliminate your hotspot by doing resharding of that particular shard. So that's the maintenance part which I want to cover in next presentation. Yes, you can all use these other features. Yes. The question is basically, with the sharded database, can I use all other EE features? Yes, I think you can, because you already have all other features licensed with you. You can use all other features. Yes. It depends. So ShardDB is equal fast as like normal OLTP. How much you can scale? That's the question. You want a horizontal scaling, right? So you want to connect your relational database to a web kind of application. So that's why shard, if you want to really horizontal scaling across the nodes and distributed processing, especially the core capacity of it, then definitely a sharding kind of distributed databases is required. But the NoSQL databases doesn't have the consistency capability. Oracle can give you the read consistency in that. That's what the pressing factor in the Oracle sharding. So where is sharded data stored? Can it be on ASM tier and a rack for each of the shards as well? Okay. So if you create a shard and you want to put a rack, you can. So that means you can create that data within the ASM. Doesn't have any problem. It's all driven through a data dictionary. So all of your query go to shard catalog database and it knows where the data is stored. So ideally, whether it is storing on ASM or it a normal disk, it doesn't matter. The reason is we just run all our query through data dictionary. Data dictionary knows whether it is on a flat file system or an ASM. It doesn't matter. Hope I have answered all your questions. If you have any other questions, please let me know. Okay. So shared catalog database is a centralized SJ itself. So shared catalog database is itself an instance. So that is, and again, we are going to create this a non-CDB. So that means it is a single SGA supported with single database. So shared catalog database is basically a single instance database. So each individual shards have their own instances running on a separate missions. So that means separate instances. So all these missions are typically tied together through a shared catalog database. You don't require any private network like these things. Well, the question is how geographically apart can the shards be? That means the distance. Well, I haven't really gone and verify how distance it can be, but ideally, if you are in a world of internet, or your configuration, I mean, your internet or your network has been set up properly between the data centers. Yeah, the latencies and all, yes, we can check with config shards what is the latency we have, everything. But I haven't really gone through. That's a really good question. I'll go back and then check the documentation and let's see, is there any limitation like more than 5 kilometers or something like that? You have to put rack extended clusters. So similarly, we may have some sort of limitation on that. I need to check with that. Yeah. So how is the shard DB backed up? Each shards need individual backups done? Yes. You have to run your Arman backups. How you take backups on individual database? You need to. Yes. So if you want to combine all backups and one together and restore all shards at once, ideally, this is your scenario. You have to take a backup of shard catalog first and all the shards with a consistent time with Arman or export, whatever it is, and then keep it safe. Rajiv, we are not discussing managing shards today. Due to time constraint, I will make another presentation, share in the blog, and the next slide, next presentations, I will try to cover that as well. Yeah. Is sharding supported on EBS as of now? EBS, you mean to e-business suite? Kiran? Thank you. Okay, so if you have any other questions, please post us. We will answer, we'll try to answer them. Thank you for joining. Thank you.